My name is Shujaur Mufti, and I'm part of RedHat. I manage global partner solutions for RedHat. And my presentation today is designing best-in-class next-generation telco cloud enabling non-terrestrial networks. Thank you all for being here today. What we will discuss today, we'll talk a little bit about 5G and cloud-native as the foundation for a lot of new communications such as NTN. We'll quickly look at non-terrestrial network overview, use cases, and 3GPP architecture, the way it is being proposed as a part of 17, 18, and 19 onwards. Telco cloud challenges and opportunities. I think we'll look at what are challenges being faced in non-terrestrial network access and the communication as it integrates with telco cloud. We'll look at some of the opportunities, how we can address some of those challenges, and lastly, I would like to present the new term in the marketplace, ubiquitous telco cloud with RedHat. 5G, as we all know, started 2018 as a part of 3GPP standards. Commercial deployment started 2020. Has NSA, non-standalone architecture, standalone architecture, service-based architecture with cloud-native as the foundation, ultra-low latency, massive MIMO, massive machine-time communication. But all in all, it makes use of dedicated set of technologies as a high level. For example, cloud-native as the base foundation, integrated with service-based architecture. Along with, we have seen quite a few momentum happening on the network slicing. How do you do an efficient resource management as a part of 5G service-based architecture, as well as microservices being enabled in that architecture. Edge computing for faster response time, because as a part of 5G, a lot of those services are actually, some of the promises that 5G has made on ultra-low latency and real-time communication. Those are being addressed via edge computing. And the third technology that is recently is on the horizon for the last couple of years, where there has been some work happen on the proprietary side. Now 3GPP has picked up, and some of those standards are being evolved and being integrated with 5G core network, part of 5G architecture to provide ubiquitous coverage. And this is our focal point for today's presentation. The global 5G engine market is expected to reach about 27.7 billion by the next 6 years, by 2030. There are different numbers based on the use cases, but overall, there's a good potential for this technology to kick it off in the next few years. And you could imagine the future for 5G NTN market is promising for the areas like maritime, aerospace, defense, government, mining, especially the areas where traditional or typical infrastructure is not possible and is not there. So all those landlocked areas are actually going to be enabled through non-terrestrial network communication, NTN access. So in general, NTN refers to any communication above Earth, right? You could imagine that the terrestrial network, when we refer, it is all the cell sites that are being deployed today as a part of global communication network. You may have some history about the Google Loon project, started about 10 years ago, which was above Earth communication, below satellites, right? So that was one way to provide communication. But any communication that is above ground, A to G, A to ground primarily for aeroplanes, normally their horizon is about 10 kilometer, and then 10,000 kilometers, and then there's HAPS, high altitude, either base station or the station, unmanned assisted vehicles as a part of drones, and then lastly the communication satellites. So all of these are actually part of NTN access. From 3GPP standpoint, they are standardizing some of the work related to satellite network, HAPS, high altitude platform stations, air to ground communication, and in broader perspective has also started to look into the technology such as drones or the Loon technology, similar to Loon technology. NTN development in 3GPP, as we know, release 15 started with 5G back in 2018. So that's where the first 5G release was actually introduced. NTN was a study at that time. 2020, that was the first time where 5G evolution started. 2020 was the time when 5G also started to come in the commercial sense as well. I'm an ex-T-Mobile. One of my colleagues is here from T-Mobile days as well, Mohil. So we started looking at that time. 2020 was the first one when we started with NSA at that time. So 5G started to deploy, but on NTN standpoint, the use cases come to horizon on 3GPP. Release 17 was the first one where they introduced two areas for focal point for NTN. One was the IoT, another one was new radio. So NR NTN and IoT NTN. And the main theme at that point was to use satellite as just a medium, transparent medium, just a transport layer. And we'll talk about it in the following slide. So TP is the transparent payload. So that was the architecture started at that time, sub 6G, primarily in NLS band. Release 18 with 5G advanced. NTN got another, got to the advanced stage where they have started to look into the interoperability between TN and NTN. So terrestrial network at the cell sites on the ground with 5G as well as non-terrestrial network like multi-connectivity, the seamless mobility between terrestrial and non-terrestrial networks, even the handoff and the mobility between NTN to NTN as well. We'll see that going forward in release 19 onwards, we'll see some of those innovations as well. So this is the current state today as 2024 release 19 work that has been started. NTN enhancements primarily are focusing on the architecture on the NTN with Open RAN. So we'll see even on the RAN side, 3GPP is actually looking into the breakdown, the deploying G-Node B at the satellite, breaking into CU and DU architecture. I'll show that architecture in the subsequent slide. And as the 6G will pick up in the next couple of years as a part of 6G studies, we'll see the NTN will get additional wheels and wings for commercialization. And just one disclaimer, you may have seen that even though there are a number of announcements today between CSPs as well as the satellite providers, but partly those deployments are either based on proprietary network or LTE network. The 5G evolution in some cases is yet to happen. Just a quick glimpse of a 5G standalone architecture with NTN access, NTN RAN. Today we have traditional RAN. I think tomorrow we'll see an NTN RAN as a part of the architecture, and we'll see some of those multi-connectivities and seamless mobility type use cases. Talk a little bit about the communication satellites, LEO, MEO, GEO. So LEO is a lower Earth orbit, right? So that's the closest to the Earth. It requires significant amount of constellations in order to, complete this. You can call it 360 coverage. Rotates fast, 10 minutes per round trip. It has the lowest latency. You may find some different latency numbers depending on the application, but just typically on the average, LEO would have this amount of latency from Earth, Earth to satellite. MEO, medium Earth orbit, the next one, right? It's also kind of rotating. Again, additional needs for constellations, additional latency, and geostationary that actually rotates with the Earth. So from Earth standpoint, it's a static satellite, but that has the highest amount of latency from the satellite communication standpoint. NTN use cases. You could imagine the NTN communication is actually making a headway there where typical infrastructure is not possible. So the first use case on the left, from my left, I'll start. Your left too. So voice and data services, right? Use satellite phones or handheld devices to commonly use in remote areas where infrastructure is not possible, the terrestrial infrastructure. We have seen a couple of capabilities that has been introduced, especially in Apple iPhone. Qualcomm has done something. Android and Apple both devices now support certain satellite communication bands today. So that's the first and basic use case for voice and data devices. Second, IoT and M2M. As I said, this was the one of the initial use cases that was actually picked up by 3GPP in order to get a bit more deeper into understanding the IoT use cases as well as addressing the additional capabilities and requirements for IoT. Again, they used in disaster management, environmental monitoring, remote locations, rural and enterprise broadband. Again, even within the United States, we see there are a lot of rural areas where the traditional ways of internet are not there. So this is a mean for rural and broadband communication over there. Direct to cell, D2C, direct to device, D2D, that has been there on the horizon for the last couple of years. We see a number of announcements there between CSPs, like T-Mobile and SpaceX is an example, or AST, AT&T, and Verizon, Kuiper. So the direct to cell communication, where you could actually use your cell phone for SMS and low data. I think part of that could also imagine on the airplane communication. I think we see quite often that now almost every airline is providing this free SMS over the airplanes. Satellite mobile backhaul. So satellite as a medium for backhaul, not the front haul. So front haul, we all know is a latency, but on the backhaul where the communication between your edge and the code data center, you could use actually satellite as a mobile backhaul communication, and other services like broadcast TV, multimedia type services by the satellites. NTN partnerships, the chart as of 2023, the chart is taken from 5G Americas. There are some dedicated providers in the satellite communication. I think I named few: SpaceX, AST, Mobile Link, and others. On the partnership side, I also named few: T-Mobile, SpaceX, AT&T, and AST. You see that the technology is 3GPP release 12, which is the LT standard, right? So they are still catching up on the 5G standard. And the rest of the implementation are proprietary implementation, like Verizon and Kuiper as an example. But and the last, at the bottom, two are starting with 3GPP, NTN. So I think ultimately what I see is more of the LTE proprietary implementations today, but slowly we'll catch up and we'll get into more 3GPP defined architecture for NTN down the line. And of course, the use cases we just looked at it, IoT, the voice data messaging, those are the high use cases as of today. Now let's start looking into the 5G telco cloud, right? So that's the second piece. How do we envision the telco cloud that is deployed for 5G network today? How this is going to be realized and evolved for NTN access? Because if you look into 5G telco cloud today, some of the characteristics, Open RAN, right? We all saw 5G started with traditional RAN, slowly got into Open RAN, CUDU, the additional capability that comes as a part of that, as a part of private 5G, and edge flexibility, right? So provided by Open RAN. So the cloud native has actually slowly transitioned into the Open RAN by running the CUDU on it. Telco edge, either MEC or the enterprise edge, cloud native has established a strong base. We have seen quite a few use cases around AI at the edge, AI and 5G, AI on 5G, right? So different areas where GPUs are actually becoming, slowly becoming a commodity by running some of those AI inferences use cases at the edge. So edge has established itself with a very strong foundation of cloud native. And of course, at the end, we'll talk about everything is automated and orchestration by the automation layer. 5G core, right? 4G core started with NFV. All transition that happened in telco with NFV slowly got into 5G, continued on. We started with, my history started with OpenStack in T-Mobile network, and the core network then slowly transitioned into, the Kubernetes-based either OpenShift or other platforms and systems. And the part of that cloud-native story is not complete without thinking about the observability, the telemetry, the data lakes, all the data that is being generated, being provided by this cloud layer upstream to the application, and is not complete without the automation and orchestration layer, right? So everything has to converge, and everything has to provide a meaning to unlock new data points and new opportunities. So all in all, private 5G is another example on top. So all in all, this is, the 5G cloud native has established its base. Now there's a new, neighbor coming in with NTN, and that is trying to make its space, integrating with 5G core in different architectures. We'll talk about in the following slides. We'll have additional requirements for the telco cloud. So cloud layer would have additional requirements, would also bring in the additional use cases and the means to integrate this telemetry and observability frameworks. Would have also impact on the network slicing. How would you do resource management in a terrestrial network plus non-terrestrial network at the same time, right? By creating a slice. So you will see the NTN access would actually, will capitalize on all this cloud-native innovation and bring in additional perspective and capabilities to unlock the next generation telco cloud. From architecture standpoint, the 3GPP architecture standpoint, there are two main architectures. One is transparent, where you're using satellite access is just as a transport medium, right? Your device connects with satellite and then comes back to the ground station that connects with your G node B. So your G node B is on the ground, your phone is connecting to the satellite while your G node B is on the ground. So in this case, you're just using satellite as a front haul, as a medium, as a transport medium. So it's called transparent payload. And you can see that the quality of service and the radio barriers flow directly goes between device and G node B and by using satellite as a medium. So that's the first architecture, transparent payload, the most foundational. And in this case, as I said, 5G core has already been running on the cloud native. So 5G core is running on the cloud native technology. In the next architecture, regenerative payload, where now you have put your G node B on the satellite itself. So in this case, the satellite you're not using as a transport medium. You're actually your quality of service flow terminates at the G node B, which is deployed at the space station. So that's the next architecture, regenerative payload, and in that case, that G node B is communicating over an interface towards 5G core that is deployed on the ground. And in those two architectures, either transparent or generative, there are some, the additional timers that you would have to adjust with your AMF, your MME if it is 4G. So you'll have to adjust some of those T timers at the access layer for attach, even just for basic attach. So those are some of the optimization that you would have to do at the application layer. But I think further down the line, we'll see how this is going to evolve in the tuning of the cloud native architecture, which is pretty much this one. Architecture number 3, which is regenerative, but in this case, you are breaking G node B into CU and DU. So you are actually following the Open RAN architecture. In that case, you have you divided your G node B into radio unit, CU and DU. In this case, DU is deployed at the space station, at the satellite, while your CU, your control unit, is deployed at the ground. And as you deploy CU and DU, they are traditionally in Open RAN architecture. They are actually deployed on a cloud technology. So they have an option of scaling In the DU, they actually require a real-time operating system, right? Real-time Linux operating system that at Red Hat that we have developed to work across DU application. So now this Telco Cloud that has been being evolved and being prepared for Open RAN, now this would have to have additional considerations going forward, and that would be the NTN access, where you would have your, between UE and DU, there will be some certain latency, but then DU and CA, you would have to account for additional latency plus the impact on the real-time operating system. And this is the last architecture just to show how this is further going to evolve in future 3GPP releases. So this is further going to be, this is part of release 19, and we'll see more and more coming in release 20, a more deeper use cases and enhancements and connectivity architecture. So in this case, device UE is having a multi-connectivity to do two different terrestrial networks, right? So this is the multi-connectivity between NTN to NTN, but there are use cases between TN to NTN, and then there is the seamless mobility across some of those networks. So those are part of additional requirements. But in this case, now you are dual connected, and then how do you manage that dual connectivity? And for those who've been in this telco industry in the past, you might remember SRVCC, single radio. We had the dual radio VCC, and then we had the single radio. And at the end, SRVCC was the winner at the end, because you wanted to have device just have one access, and then within that access, you actually backend change the technologies when we have to hand over between different radio networks. So we'll see how this is going to further evolve in 3GPP, but I think we'll see more and more and very granular architectures and connectivities for multi RAN scenario between TN and NTN. Telco Cloud challenges with NTN. I think you could, as we looked into the architecture, there are some differences between terrestrial network. It's not as ultra low latency as was promised by 5G, right? So there would definitely be additional considerations. There are some other challenges, as you could imagine, the scale of that connectivity that actually provides on the horizon. So I'll start from left, integration complexity. So now this is a new framework, new architecture. In this case, you may not be able to see what you are connecting to, right? So your interfaces, half of your interfaces are at the satellite, for example. That's where you are terminating, and then you're terminating on the ground. So you may not be able to, physically send somebody to do that kind of thing. So there will be some integration complexity challenges in terms of the interfaces and how would you operate that infrastructure. Latency and quality of service, right? So there will be additional consideration. If it is LEO, about 50 millisecond time that you would have to consider in our application, as well as in the cloud layer. If especially, I think I said the DU requires this real-time Linux operating system, so it can run fast on the DU application. Some of the timings, the GNSS clock, the precision time protocol, I think the additional consideration will be there in order to manage latency and the QoS. Scalability and capacity. As I said, 5G with cloud native has conquered a good handle on the scalability side, where you have this now architectural flexibility to do, for example, do network slicing. You're able to manage your resources efficiently through network slicing. So some of those additional considerations would have to be done, including this NTN access as an input to that. Network slicing and orchestration, part of the same framework. Additional considerations about the resource management at the access level, plus at the core level. Once you split the architecture, would bring in additional stuff there. Plus, if you consider edge, if you think about in some use cases where you may have to deploy some edge in order to leverage this faster response time. So all of that would have to be considered by this whole, the autonomous operation, the automation and orchestration that you have built on top. Interface and spectrum management, I think that is one of going to be a big challenge because the shared spectrum is mainly where this technology operates. So I think we'll We'll see the interference and the additional frequencies for spectrum management will come in play. Security and privacy. And now, we always talk about man-in-middle attack for Wi-Fi networks. Now your man is on the space. Now your horizon is big. So how would you make sure that your communication upward and downward is all secure and private? So additional requirements will come for security and privacy, encryption, extras. Regulatory and legal, I think that is going to be, I would say, the biggest hurdle in here, because today, terrestrial networks traditionally are confined into geographic locations at the market level, region level, country level. Now, once you are above the ground, you actually have more geographic area to cover, especially the satellites. They can 10 minutes they can complete the whole orbit around the Earth, right? So that means that there would be, and especially the way they will provide communication services across different geographic regions, there would be an additional regulatory and legal requirements. We have seen some of those coming up, pretty obvious. Cost and business case, it's not an easy, the cost-effective technology to work with. So that means you'll have to figure out how the business justification is about to go, right? Your CapEx and OpEx, how that is going into play as you enable this technology for the use cases. I mean, is it worth the ROI? How to address these challenges? Some thought process, not a conclusive list, right? So some ways. First, software-driven approach. I think the traditional, as an example, the GNOB, the appliance-based model may not work. The more software-driven that we have in our approach would actually help better, because now you're able to dissolve your components, and then you're able to strategically place some of those components in the architecture. Like DU, you have this lightweight component deployed at the satellite, but then the CUs can be deployed in different geographic regions. And then based on how you wanted to provide that connectivity, your CU could actually control maybe a certain geographic area. So you'll have to think about some of those, the software-driven approach for your architecture that would actually help, further benefit into tailor it for the use case, as well as, make it the CapEx and OpEx justification. Open and secure ecosystem. We always talk about openness, and then we talk about security, maybe the, opposite side of the coins. But now we have to holistically look both together at the same time, because security is important. It's the spectrum is broad, right? It is, it is the based on the geographic coverage of that. And the open standards drive innovation. You cannot have the closed door and then shut down from everything. The open source drives the additional communities, the brainstorming, the additional capabilities and flexibilities. So you have to think from both perspectives. How would you take both together in order to drive innovation in that space? Edge for latency and reliability management. I think we talked about, in some cases, we may have to leverage edge for the critical operations, the real-time operations you actually execute at the edge. But then the operation that does not require the real-time sensitivity, so you actually relay that back on the satellite medium, on either at the transport or regenerative mode. So you would have to leverage this edge for to deliver this faster and real time. But the non-real time and other use cases, you could actually from edge you could actually leverage the backhaul. So you'll have to have how you connect these two pieces together in order for a single use case. You'll have to think about that. Application modernization and optimization, the multi-layer optimization, again, kind of in the similar theme, that you cannot have these, the big monolithic legacy applications around that. You also have to evolve your microservices applications for account for QoS latency, the time sensitivity and criticality. Your application, just like device, we said have multi-connectivity across two networks, terrestrial and non-terrestrial, and the application within the device is making a decision. If I need to make a 911 call, I rather go to terrestrial network. right? Not the satellite. So some of those enhancements would have to have at the application layer in order to use the right network for the right traffic type. And then lastly, the smart use of automation and observability. I think for me, one of the key area that we often miss and we come back and realize that we should have done that better is observability, because automation, you still build something to automate, but then you miss the whole telemetry and observability, because that is your key resource. A lot of the AI actually depend on those data points to actually come in place. So I think that will be the key part of the proposal as you enhance and extend your telco cloud in order to account for NTN access. Conclusive slides, last couple of, right? So the concept is you don't have to reinvent the wheel. The telco cloud is there. It has been founded. It has all the ingredients with automation, orchestration, observability, edge, private 5G, enterprise G, 5G core, right? The unified architecture after the service-based architecture. So it has all the ingredients. You extend, relook that architecture, and how would you further extend to the NTN access, right? So your underlying theme does not change. Your underlying theme should still be develop once, deploy anywhere, and operate autonomously, right? So you continue with that theme. And that's where I said I will introduce a new term today, ubiquitous telco cloud, because as NTN provide ubiquitous coverage, which is everywhere, I think your telco cloud should also be a very similar. It should also be able to operate in any access, because NTN is not the last access that 3GPP is introducing. There is additional access. We'll see VMR, vehicle mount relay. We'll see, I think, the railway mobile communication. So that is coming up in 3GPP for the faster, the train communication. So we'll see the additional access types will come in play. So you should think about building this, the ubiquitous layer at the telco cloud as well. And of course, on the top is your visibility, your observability, and then the management and orchestration, the whole multi-cloud management. The last slide for today, just giving you a bit of gist of what at RedHat we are doing. We are actually thinking along the same lines. That's why it's a ubiquitous telco cloud with RedHat. So we have this top automation and orchestration with Ansible, ACM. We're bringing in OpenShift AI in order to leverage this AI architecture, the capabilities within the platform to run some of the modelings. The OpenShift is a platform, we call it horizontal or a common cloud platform, which as you deploy from edge to core, so this is one platform that you have to deploy edge to core, and you could have this, monotonous operations from edge to core. Now you extend that edge to core to further, to the non-terrestrial network access. And at the bottom, as I said, it is any cloud, it's public cloud, private cloud, edge cloud, NTN access, or NTN IoT, or enterprise edge. It's all any cloud where you deploy. It's the same cloud platform powered by AI, but at the same time, we're also looking into the NTN access for transparent payload as well as regenerative payload with some of the partners who are actually enabling those use cases with the communication service providers, how to account for some of those additional considerations for real-time operating system at the DU level, additional requirements at the CU. So some of that work has already been started. With that, thank you so much. Thank you for having me today, and thank you for making the time to attend this. I don't know if we have time for Q&A or... I did not check the time. Sure.
So for the F1 and basically your interfaces, right?
Mm-hmm.
That goes on the air. NR is different, right?
Right.
Does 3GPP have special considerations to handle that transport?
Yes, so it does. So I think in 3GPP, they have started to look into it. As I said, the first wave was only the timer in the 5G core. Those T3, 4, 1, 5, whatever those timers are. So I think those are what they have started to list down. What are the additional millisecond requirement, latency requirement for those? I think on front haul, there's a lot of work that has to happen. Because on the front haul, there's a lot of innovation that is happening in the industry as well. ION, I don't know if you heard about it, there's a new standard that is coming up. So I think front haul will see more and more evolution, and of course 3GPP adapting and creating those additional requirements in there.